topic called as conversion of galvanometer into ammeter and voltmeter. Whenever in our laboratories, if only galvanometers are available and resistance boxes are available and we don't have ammeter and voltmeter, in such a cases we can convert our galvanometer into required range of ammeter and voltmeter. So that is the theory here we are discussing. So first thing is regarding ammeter. How to convert a given galvanometer into ammeter? How to convert? It is not so easy that you are going to remove the parts and you are going to connect like ammeter parts. So it is just a combination of another resistance with it, so that the combination is behaving like that ammeter and the readings are going to come similar to the ammeter reading. ಆ ಜಾಗದಲ್ಲಿ ammeter ಬದಲಾಗಿ ಈ ಎರಡು ಕಾಂಬಿನೇಷನ್ ಹಚ್ಕೊಂಡ್ರೆ ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಅದೇ ತರದ ರೀಡಿಂಗ್ ಬರುತ್ತೆ, ಮ್ಯಾಚ್ ಆಗುತ್ತೆ ಅದನ್ನ. ಸೊ ಅದು ವೆರಿಫಿಕೇಶನ್ ಅಂತ ಯು ಹ್ಯಾವ್ ಇನ್ ಯುವರ್ PUC ಸೆಕೆಂಡ್ ಇಯರ್ ಲ್ಯಾಬ್ರೋಟರಿ ಸೆಕ್ಷನ್. ಸೊ ಕನ್ವರ್ಷನ್ ಆಫ್ ammeter and galvanometer, you can do it by yourself and verify by yourself. One ammeter you are using, along with that this combination you are using, and you are making both the readings to be obtained and you are going to match those readings. You are going to get the error between those two readings. Fine. So what you did in that conversion you are doing. So what you are doing in practical laboratories, today we are discussing in our theory that is related to your theory topic. So here you can see over that first one, these are asked for 3 marks, don't forget about that. These are asked for 3 marks. Or else one single question also comes from this, like 1 mark question. How we can convert a galvanometer into ammeter? A main part of this is the galvanometer can be converted into ammeter by connecting very small resistance in parallel with the galvanometer. You have your galvanometer. Take a very small wire which has got very less resistance. Connect in parallel. That small resistance we call it as a shunt resistance. The meaning of that, it is used for very less values. A small resistance connected in parallel, a very small resistance connected in parallel, this combination I have shown with the dotted circle here, this combination is behaving like ammeter. This combination is behaving like an ammeter. These two, whatever the reading comes, what kind of readings you are expecting here? We are expecting the divisions. It is fixed. This is fixed, no doubt. This is fixed value, less value. But here you are going to observe the deflection in the galvanometer. That deflection will make you to understand how you are getting the readings, and you can note down those and you can take the help of LC values and you can convert them. The calculation is required to get the ammeter converted readings. Okay. So here this is about that. I am repeating only one sentence. How can we convert a galvanometer into ammeter? A galvanometer is connected with a small shunt resistance in parallel with it. It works like a ammeter. I am repeating. Small shunt resistance connected in parallel with the galvanometer behaves like an ammeter. Hope so it is clear. The next diagram is here with you. You need to write that sentence what I said. You need to draw this diagram and you need to write this formula. What is this formula? So they are showing about that I is the main current, IG is the branch current, IS is another current which I didn't show here. So IG is the current through the galvanometer. Less portion, branch current means your main current is getting split. So IGG by IS. So current is getting divided. So using that shunt resistance equation, G offers resistance. The galvanometer also offers resistance. Galvanometer also opposes the current, little portion of current. ಅದರ ಹತ್ರನೂ ತನ್ನದೇ ಆದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಪವರ್ ಇರುತ್ತೆ, ಅದನ್ನ G ಅಂತ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಗ್ಯಾಲೋಮೀಟರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ G ಅಂತ ತಗೊಂಡ್ರೆ ಅವರ್ ಇಕ್ವೇಶನ್ ಫಾರ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ S is equal to IgG by I minus Ig. What are these? Ig indicates current through the galvanometer. Ig indicates current through the galvanometer. Capital G indicates resistance of the galvanometer. Resistance of the galvanometer. I indicates the main current. I indicates the main current, total current. Ig again indicates the current through the galvanometer. Okay. So this is the end of your conversion of galvanometer into ammeter. You need to use this formula. You need to connect like that as shown in the diagram. And you need to record the readings or tabulate the readings. Substitute in this and you are going to get the readings. While doing, you will come to know very easily still. So here is the next and last topic. So conversion of galvanometer into voltmeter. Conversion of galvanometer into voltmeter. How can a galvanometer be converted into voltmeter? Now exactly reverse of this. Reverse of this ಅಂತಂದ್ರೆ ಇದನ್ನ ಮೇಲೆ ಇದು ಕೆಳಗಡೆ ಹಾಕದಲ್ಲ. Fine. Small resistance in parallel it was. Small resistance in parallel. Now what is the opposite of parallel? Series ಇರಬೇಕು. Then what is the opposite of small? High ಇರಬೇಕು. Yes, that's a common sense. So here is that when galvanometer is connected with the high resistance in series, when the galvanometer is connected with the high resistance in series, the combination behaves like a voltmeter. The combination behaves like a voltmeter. How can we convert a given galvanometer into voltmeter? By connecting a very high resistance in series with the galvanometer. We can make the galvanometer to work like a voltmeter. This is the diagram, circuit diagram. You can see here I is the main current and in series the current remains same, as you know already. So here is that formula which we need to use, and you can understand here is the capital G which gives you some resistance taken in the form of G value, and this is another resistance which is very high, 5000, 3000 above we are using, 3000 above we are using, and here we are using in terms of 0. or 1, 2 like that, very less values we are using here. So here is that two resistances are series, here two resistances are in parallel, here the parallel combination formula is used to get this equation, and here series combination formula is used to get this equation. Derivations are not required for you, only the main final equations are needed, so it is there. So R is equal to V by Ig minus G. So where V is the voltage or the potential, capital G is the resistance of the galvanometer, and Ig you know already, that is the current through the galvanometer. And here is the end of your 4th chapter. Fine, just concentrate well enough. If you have any doubts, you can ask. Here today I am discussing regarding the current sensitivity and voltage sensitivity related to your 5th chapter only. Current sensitivity. After discussion of your moving current sensitivity, the sensing of current. So deflection per unit, fine, deflection per unit current flowing through it, flowing through any conductor is called current sensitivity. Current sensitivity definition, 1 mark, then formula another 1 mark, unit another 1 mark. So rarely asked all togetherly as a 3 marks, but they are asked individually to write the current sensitivity definition or unit sometime. So current sensitivity is given here, and the formula comes to be as a IS indicating the current sensitivity, and theta by I represents that theta is the deflection produced, divisions given in terms of theta, and per unit current flowing in it is given in the denominator. So theta by I from our previous formula that comes to be as NBA by K, where K is called a constant, as you know. A is area of the conductor, B is magnetic field in of that, and N is number of turns in the coil. Unit of this current sensitivity is division per ampere. Division per ampere. The next is our topic is voltage sensitivity. Next our topic is voltage sensitivity, similar to current sensitivity, denoted as Vs. Deflection per unit voltage. Deflection in the conductor per unit voltage is called as the voltage sensitivity, and the formula comes to be as Vs is equal to theta by V, as you saw I wrote here theta by I. So theta by V, and you should understand well enough. So this theta, and you can see what a theta I can replace with this NAB by K, I by V. I by V comes here. So because here theta by V, then NAB I by K remains for theta. From this formula, NAB by K into I remains for theta itself, because I by theta is NBA K. If I want only theta from here, I should be multiplied here. I should be multiplied here to get theta value. So to get theta value, I must be multiplied. Mutate. So theta by I, so we can see that after cross multiplying NBA by K into I, NBA by K into I. So this V as it is in the denominator you can see here. The next is about regarding use V as IR using your Ohm's law. Take V as IR from your Ohm's law. Then substitution gives us the cancellation of your current. So only NAB by KR. NAB by KR is voltage sensitivity formula. Voltage sensitivity formula is NAB by KR. And what is its unit? The voltage sensitivity is measured in terms of division per volt. Division per volt. Remember, division per volt. Okay. So you can see over that